स्टार्ट हुआ क्या देखता? हेलो चेक चेक चेक. Hello check. Okay. Hello everyone. Welcome back again to our channel Coders Arcade. This is Saurabh, and today again we are continuing with our DSA live session in Java. Okay. So last Friday we have been discussing some applications of binary search, right? So if you remember, we had covered a topic called the square root using binary search. Okay. So we have successfully covered that topic, and also I have showed you how to write the code regarding that. Okay. And yes, today we will be continuing with the same topic, applications of binary search, and today we will be covering one more question, and I think I have given you a brief idea about the same. Okay guys, let me do one thing. Let me also open the same content in my mobile so that I can see who is giving any comments and all. Okay, so yep, fine. So as I said, binary search applications, very important topic as we all know, and very frequently asked in the placement drives. So square root using binary search, if you haven't watched that video, make sure the live session has been uploaded to our YouTube channel only. Go there and learn from this. Okay, today as I said, we will learn another application. I have already given you an idea of how to solve that. The question is first and last occurrence using binary search. I am writing BS, okay, binary search. Fine. So let's try to understand about this. Okay, this is an application of binary search itself. Okay, binary search, and in the question sometimes they might have written log of n. Ultimately the end goal is same. We have to use binary search to find the first and last occurrence of a number in an array, and that array will be sorted. Okay, otherwise obviously you cannot apply binary search. So let's take the array int arr is equal to, say for example, 1 2 3 3 3 3 4 5, and there can be more elements also, 6 for example. This is a sorted array, and here we have to find the first, last, and also let's take one more, the total occurrences as well, because if we can find the first and the last, we can easily calculate the total. I had already given the idea about this in the previous video. Okay, so the key value here is 3. So we have to find the first occurrence, the last occurrence, and the total number of occurrences. Okay, if you can see carefully, let's talk about the indexes. We already know the index starts from 0, 0, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9 elements. So index 0 to 8. Fine. So the first occurrence is this, of this value, the key 3, which is 2. Okay, 2. The last occurrence is, if you can see, 5. Okay, the total occurrence, if you want to find, the formula is last occurrence minus first occurrence plus 1. I had already told you about this in the previous video. Okay, so last occurrence is 5 minus 2. Actually, if we write last minus first, what will happen is it will be 3. But if you observe 1, 2, 3, 4 times, the key 3 has occurred 4 times in my array. So the answer, we need to add 1. 3 plus 1, that gives you 4. This is the answer. So once you can find out first and last, the total becomes very easy to figure out. Correct? So let's try to understand how to apply binary search in this sorted array to find the first, last, and total. Okay. Many companies, guys, many companies, like let me give IBM, Wipro, you have what is that company's name, Genpact. Sometimes you will get it here also. It depends on the company. See guys, Genpact has a IT part also, they have their own BPO part also. I'm not talking the BPO part, I'm talking about the IT section. There you have hirings on SDE, SDT and all. Okay, and also guys, Infosys, these are most frequent companies, they ask you questions on binary search. That's why I'm taking up this topic. Okay, now let's try to understand this. I'll draw the array again. One, two, three, 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 4, 6. 1, 2, 3, 3, 3, 3, 4, 5. Let us take 6 also. Okay, so I'll just break it down like this. Try to understand. Normally, what do? You find the mid value. Correct. The mid value you find by taking start plus end divided by 2. So let's take the start value. This is our start. This is our end. And let's write down the indexes also. 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay. And so based on this, it will be 0 plus 8 divided by 2. That is how much? 4. Fine. So according to this, what do you do after finding the mid in binary search? We calculate one very important thing. So I'll write like this so that you can understand. Okay. So let's say I am finding the first occurrence. First thing first, if our ARR of, this is our array, if our ARR of mid is equal to the key, in that case, if you see carefully, our ARR of mid is what? It is ARR of mid is 4, right? So ARR of 4 is what? If you see 0, 1, 2, 3, 4, it is 3. And what was our key? The key that we are searching, that is also 3. So it is matching, and we need to find the first occurrence of that key, right? So what you will do? Think and tell me. We need to find the first occurrence. Now think practically, when you are in a sorted array, where will be the first occurrence of some number be? We are starting from ascending to descending order, right? Ascending to descending, I beg your pardon, we are starting from the beginning to the end in an ascending order sorted array. Where will the first occurrence be? It will be to the extreme left hand side, correct? When I am trying to find 3, the first occurrence of 3 will be to the left hand side because it is a sorted array, and the last occurrence will be to the extreme right hand side. Therefore, once you have find the value, go to the extreme left to find the first occurrence. Okay, because obviously if I have 1, 2, 2, 2, 2, 2, whatever it is sorted. So the first occurrence has to be to the extreme left, and the last occurrence has to be to the extreme right. This is a simple funda that you have to use here. Okay, so what you do, just store. Initially I will take a variable answer is equal to -1, saying that the index -1 does not exist. Now what you do, you just store the answer. Just say answer equal to mid, store it, and go to extreme left, because you are finding what? First occurrence. Make sense? It's very simple. So how do you go there? End is equal to mid -1. What we are doing, we found that this is the occurrence of any value. Let's go this side. How will you go this side? This is our end will shift this side, so that we are reducing the space so that you can search on that part. Make sense? That is what our target is. This is for first occurrence. Okay. Similarly, for the last occurrence, what will you do? If our same condition, array of mid is equal to the key, store the answer, because you might have only one element, and in that case the first and the last occurrences will be ditto same. Okay. So in that case, just store the answer. If you are finding the last occurrence, go to the extreme right, this side. So go to extreme right. How will you go? Other time you were shifting the end this side, now you will shift the start this side. This side you will have to find out. So start is equal to mid plus 1. Make sense? Otherwise, if you haven't found it, then you already know the base cases. What will happen? You will just say, suppose it is not matching, then you will write if our ARR of mid is less than the key. Obviously, that means we are on the wrong side. Then you will say start equal to mid plus 1. Otherwise, else end equal to mid minus 1. This is common. And this same thing that I have written here, okay, this will be updated here as well. Make sense? The same thing that I have written has to be done on the other side also. Did you understand? Make sense? So I hope you have understood. Just remember, starting occurrence or the first occurrence, go to the extreme left. Last occurrence or the ending occurrence, go to the extreme right. Otherwise, it is absolutely same. And what have we done? We have used binary search to find this. Therefore, the time complexity of this operation will be logarithm of n. Simple as that. Hope you have understood this. Any doubts, any queries, I am there. Please post it in the comment section. Now let's do one thing. Let's go to our editor and try to write down the code to find this. Okay. I'm creating a new Java class saying first, last, total occurrences. And guys, it's your request, your support that makes our channel prosper. So please, again I am telling you, if you really like the content that we are bringing, please make sure you subscribe to our channel and hit the bell icon, because that is the least you can do to motivate us to bring better content to you. Okay. So let's get started and write it down. Fine. Till now I can see there are no comments. It's fine. Okay, let's get going. As I said, let me create a method. First occurrence. What do you need from the user? I hope it's visible. Okay, yeah, fine. So I need the array and I need the key. Okay, so what I'll do, the return type should be int, right? We are returning the index. I'll copy the same thing, paste it here, and I'll copy it one more time. Okay, this time I'll write last occurrence. This time I'll write total occurrence. Okay, these three. Fine. So as I said, first thing first, our start value is 0, end value is what? Length minus 1, ARR dot length minus 1. Okay, and we already know the base case. I'll take the answer variable is equal to -1 by default, and I'll say if our, let's take the while loop for the base case. We already know that start should be less than or equal to the end. The start value cannot go beyond the end, because otherwise we will be out of bounds. Correct? Here let's calculate the mid. And in the last video I asked you but nobody answered me. Again I am asking you the same thing. I already explained why is the start formula written like this, n minus start divided by 2. This is the optimal formula to find the mid in any binary search algorithm. Tell me why do you write it like this? Anybody in the comments if you know that. Fine. So as I said, let's write the conditions. If our ARR of mid is equal to the key that we are finding, we found the key. Now we need the first occurrence. So let's go to the extreme left hand side. Okay. Go to the extreme left. But before that, you have to store the answer. So store the answer and go to the extreme left. Okay. So how do you do it? Answer is equal to mid. Mid is representing the index. Okay, guys. And end is equal to mid minus 1. Make sense? This is the condition. We are going to the extreme left hand side to find the first occurrence. Otherwise, we already know the next thing. Else if ARR of mid is less than the key is to the right. So, you have to shift. This is basic binary search, the normal one. Start is equal to mid plus 1. Okay. Else, we already know what we have to do. End is equal to mid minus 1. Understood? I hope this is clear now. And afterwards, if you don't get the answer, you can just say return your answer. Whatever is stored in the answer variable, just return it. Make sense? Now, guys, one thing. I'll just copy the same code because it has to be used again. I'll copy this, go to the last occurrence method, and here I'll paste this. But this time I'll make a change. As I said, for the first occurrence, we are going to the extreme left. For the last occurrence, we will be going to the extreme right. Okay. So let me just change it here. This will be right. And how do you go to the right? We shift the start value this time. Start is equal to mid plus 1. Okay. Other things will be ditto, absolutely same. Only change, guys. Just remember, for the first occurrence, extreme left, end equal to mid minus 1. For the last occurrence, extreme right, start equal to mid plus 1. Okay. And then other things will be absolutely same. And in this case, let's calculate the total occurrence now. So what I'll do, I'll create variables. First occurrence is equal to, I'll call that method first occurrence by passing the array and by passing the key value. Okay. Similarly, in last occurrence is equal to, I'll pass the array and the key, and I'll just calculate the total is equal to last minus first plus 1, and then we'll return the total. Okay. Hope this is all clear. Now, in the main, what we will do is, we'll just call them by creating our array is equal to, let's say 1, 2, 3, 3, 3, 3, 4, 5, 6 for example. And then let's take our first is equal to first occurrence, our array, comma, let's take the key as 3 as discussed, and int last is equal to last occurrence, take the array and the key 3 itself, and int total is equal to total occurrences, array, comma key, key is 3. Fine. And finally, let's print all of them. First occurrence of 3 is plus first. Let me copy the same line, paste and paste. This will be last and this will be total. But space, let us change this to last, let us change this to total. Okay, so let's run this and check if it is working or not. Okay guys, you can see here first occurrence is 2, second index, the last occurrence index is 3, and the total is 4. If you see carefully, as discussed, 0, 1, 2 second index, 3, 4, 5 fifth index, and total is 4 times it is occurred. Okay, so this is about this code. Hopefully you have got it. Any doubts, anything, please post them in the comment section. Okay, and guys, it's all about your interest, guys. Okay, if you are really liking and if we are seeing more viewers, then obviously we will be continuing and giving you the best, and yes, that also motivates us to create content. But otherwise, if we are not getting that kind of responses, it will not motivate us to create contents like this. Okay, and yes, because I promise you we'll be bringing up more content like this in future, and yes, stay tuned and please subscribe. Okay, just don't come watch and go away, please subscribe also. So I hope you have liked it. If you have understood this, give a thumbs up. If you haven't understood also, just let me know, I will try to clarify all your doubts. And with this question or this topic has been finished. Okay, now let's do one thing. Let's try to figure out and understand one more problem. Similarly, guys, lots of interviewers ask this question, so I will take up that question now. Very important question, so try to understand this. Okay. Keep this. Just a moment. Okay, I got it. Missing element in an array using binary search. This question has been frequently repeated in lots of tech interviews. Okay, and normally people do one thing. I'll tell you the basic logic also. If binary search and all is not mentioned, then they will say something like this. For example, let's take 1, 2, 3 and 5, 6, 7, 8 for example. Okay, how many elements are there? There are 7 elements. If you can see, the n value is equal to 7. So in this case, if you are trying to find a missing element, I can easily see that 4 is the missing element, correct? But here n is 7, that means it will be plus 1, that is 8. Obviously then only there will be one missing element in this array, and you can see these are actually natural numbers. One to n, makes sense. Here n equal to 8. So normally we know the formula, the sum of natural numbers, Sn equal to n into n plus 1 divided by 2. Make sense? So here 8 into 8 plus 1 is 9 divided by 2. This is 4. This is actually 36. This is the total sum of all the numbers from 1 till 8. Okay. From 36, just subtract the sum of the array. Sum of array. Understanding? So if you see here, it will have 1, 4 less. Try to understand. 7, 8 is 15, 15 plus 6 is 21, 21 plus 5, 26, 26, 28, and then 30, 31. You have 31 here, okay? And I think I've done some mistake. 15, 21, 27, okay? So 26, 32 is the answer. I beg your pardon. So it will be 36 minus 32, and you have got actually your missing number. So this is one way of doing it when you actually haven't been mentioned about anything like binary search. But when they mention binary search, then you have to do it in a different way. Make sense? So then let's try to understand how to do it when they have mentioned either binary search, or they have mentioned log of n. How will you do it in this case? Okay, let's try to understand this. 1 second. Okay, no comments yet. All good. So try to understand this. Very critical and very interesting also. So try to understand this. Not so difficult. I have 1, 2, 3, 5, 6, 7, 8, 9, 10. Let it be, doesn't matter. Fine. You can see the number will be given. In this case, the number of elements is how much? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, the length of this array is 9. So imagine I am giving you one important case. Case 1. Just remember this. Case 1. When n is given and no missing elements, for example, let me say what I am saying. 1, 2, 3, 4, 5, 6, 7 and 8. If you see, you cannot find out any missing element in this case. 1, 2, 3, 4, 5, 6, 7, 8. Nothing is missing, but in this case, they will say n equal to 9. So what does that mean? Or in that case, let me say n equal to 8 only. Doesn't matter. Let me say n equal to 8 only. All the 8 elements are there. So which can be the missing element in this case? It will be the next element. So you can return n plus 1. That is 9. So this number 9 will be the missing element in this kind of cases, when you did not find any missing element. Otherwise, what should you do? In this kind of cases, where we have a missing element. See, 1, 2, 3, 4 is missing here. See, 4 is not there. This kind of cases, you have to do it in a different way. Okay, let's try to figure that out. Case 2. 1, 2, 3, 4, or 6, 7, 8, like this, something like this. Here, let's write down a proper way of doing something here. Okay, I'll take one more array to make you understand one thing. This is 1, 2, 3, 4, a normal array where all the elements are present, and I have the indices 0, 1, 2, 3. Okay, so I can write a formula. Element is equal to, these are the index. Okay, this is element and this is index. If you carefully observe, element equal to index plus 1. 0 is the index, 0 plus 1 gives you this number. See, I plus 1, I plus 1, I plus 1, I plus 1. So E is equal to I plus 1 can be a formula. Make sense? 0th index 1, first index 2, second index 3, third index 4, like this. Anywhere that kind of thing happens, actually what happens? There is a missing element where this is not matching. When I is element is not is equal to I plus 1, there is a mismatch. This mismatch we have to figure out. Let's see how we will figure out. Okay. Try to understand this. Let's take the indexes 0, 1, 2, 3, 4, 5, 6. Okay. Start. This is n. Let's calculate the mid value. Mid equal to start plus n by 2. Okay, that means it will be 0 plus 6 by 2. That is 6 by 2. That is 3. Okay, now let's try to see what we need. What will be the condition? Can you tell me? What should we write? If ARR of mid not is equal to what? What have I written here? If element is not equal to element plus index plus 1, right? So, if ARR of mid is not equal to mid plus 1, what will happen? Tell me. Anybody? Whenever there is a proper match, the value and it will match, right? See, element equal to I plus 1. In this case also, if this is not matching, that means we are at the correct place. We will be able to find it. Okay, otherwise, if it is matching, then no problem at all. Let me write like this. If our ARR of mid is equal to mid plus 1, let me try to say what I am saying. Check, we got mid equal to 3, 0, 1, 2, 3. In that case, I am checking this. Let's try to check this. What is ARR of mid? ARR of 3 is equal to, mid is 3, right? 3 plus 1. What is this value? ARR of 3? The value is 4. Make sense? 4 is equal to, mid is 3, 3 plus 1, 4. This is matching. That means, if this value is matching, that means all values on this side will be also matching. Make sense? Did you understand what I am saying? Whenever the index value plus 1 is giving you the number, that means the missing number cannot be on this side. Okay? So we need to go on which side? We need to go this side to find the missing number. Correct? So what will I do? I will just say start is equal to mid plus 1. Always. Make sense? Understood? Otherwise, if something like this happens, this not equal to case happens, that means we are actually at the correct position. Okay? In that case, what can happen? We need to go to the other side. See, try to understand. Again, I will tell you. Let's talk about this now. This place. Imagine this place. What happens here? What is ARR of mid? Imagine 5 is our mid. Mid equal to 5. What is ARR of 5? ARR of 5 is equal to, normally it should be 5 plus 1, right? But is 5. ARR of 5. 7. 7 is not equal to 5 plus 1. 7 not is equal to 6. Mismatch. Make sense? Whenever you have this mismatch, we have to go to the other side. What will you do? End is equal to mid minus 1. Whenever this mismatch is happening, that means this area has a problem. So you need to go this side. Okay? The other side. So while going to the other side, you have to check two things. When we are going to the extreme left hand side, imagine from here we are going to this side. We can reach one place where our mid becomes equal to 0. Beyond that we cannot go, right? Yes, we cannot go beyond our mid value because array has 0 index only. Beyond that we don't have anything. Okay? So while going to the right hand side, we don't have to bother about anything. That is fine. Just start equal to mid plus 1. When everything is working fine, that means when our index plus 1 gives you the value, all good. 1 plus 1 gives you 2, all good. 2 plus 1 gives you 3, all good. So this part is all safe. So I will never find the missing element on this part. Obviously I have to go this side, somewhere on the right hand side. So for that I am doing start equal to mid plus 1. But whenever there is mismatch, see this 5 plus 1 is not giving you 7. In that case, the answer cannot be on this side. Already this side is misaligned. The answer will be somewhere on that side, the left hand side. Therefore, we do end equal to mid minus 1. But while doing this, there is something wrong with the internet. Just a moment. Okay, it's fine now. So whenever we are trying to go to the left hand side, we have to check two things. Try to understand this. While going to the left, we have to consider one thing very important. If our mid is equal to 0. We have reached here. Or there can be one more case. Okay, mid plus 1 is equal to the key. That can also be the case. Okay, what does that mean? Or we can write, rather than writing key, we can write like this. Somewhere we might get mid plus 1 equal to the mid value. What does that mean? Think and tell me. Figure out and try to tell me what I have written. So I will write something like this so that it will be easy for you to figure out. Okay, let's write down 1, 2, 3, 4, 6, 7, 8, so that you can understand. This is 0, 1, 2, 3, 4, 5, 6. Okay, try to understand. Very important. I said while we are going to the left, we cannot extend beyond 0. That is one point. The second point that I am saying is, while we are actually checking this, there can be one more scenario when our yes, we can get something like this. This will be more easy for you to understand. We'll just do one thing. Okay, see, this is the gap where actually the problem is happening, right? Make sense? So try to understand this. What is this number? 3. And if I write something like this, ARR of mid minus 1 and is equal to mid. Can this happen somewhere? Can you just try to figure out what I am trying to say? See the condition. I have the code here. Let me just show you so that you can also understand. See. Okay. Imagine I got mid is equal to 5 somehow, and I am getting something like this. I am writing ARR of 5 minus 1 is equal to 5 somewhere. Can we get this scenario somewhere? We can get it. When will you get this? Whenever this 5 and this 5 are coming like this. Okay, that can happen. In that case, here you can see this thing is happening. 5 minus 1 is equal to the mid value. That can also happen in that case. Whenever you are having this point, then you will get the answer. So whenever you are going to the left hand side, make sure you see that the mid is not 0, or else you see this condition. Whenever this happens, this is not equal, this should be equal, okay? Then only you can compare, right? This is a comparison operator. So let me show you the code so that you can understand this. One second. Yep. See the code base. As I told you, here is the missing element code. I said if it is not equal to mid plus 1, in that case what is happening? We are going to the left hand side, right? Then what are we checking? We are checking mid is not equal to 0. If it is 0, that means in that case what is happening? If our mid is 0 here and we have the missing element here, at 0th index what is the value? It is mid plus 1. 0 plus 1, that is the answer. Here mid plus 1 will be the answer, 1. At 0th index 1 should be the answer. Similarly, there will be one condition where we are getting something like this. If you can observe carefully, you will understand this. See the code. Or ARR of mid minus 1 is equal to the mid. That means what? In some case, I can get something like this. See, try to understand. Here, in this line that I'm junction that I'm drawing, here this case is happening actually. Mid minus 1 is equal to in the mid. Try to understand. In that case also, try. Think, I'll give you the proper example. Imagine this is 4. Fine. I am writing ARR of 4 minus 1 is equal to 4. It will happen here this side. See, what is the mid? ARR of 3 is equal to what is the element? The mid value only 4. 0, 1, 2, 3. In that case, I have got this value 4. Makes sense? Then what is happening? What will be the missing index here? Then I have got the missing index. It is 3 plus 1. That is the missing index. Which is that? 4. Then also you are getting the output. Got it? So imagine mid not being this or mid not being this. In both the cases, return mid plus 1 only. Because 0th index we should have 1. And in this case also you will be getting plus 1 only to get the correct index. Okay, that is how you can calculate this. And the code is here. You can just figure out the code from here. See, as I said, 2 examples are given here. Try to understand this. Let me just zoom in. Observe. 1, 2, 3, 4 is the missing element here. In the second case, 1, 2, 3, 4, 5, 6, 7, 8. Obviously, I told you the other case also. In the second case, it will be what? 9 will be the missing element. See, first one 4, second one 9. Guys, if you need the code, let me know in the comment section. I'll share you the code. Okay. So yet no comments. I don't know what's happening today. Nobody has responded and said anything. On it. Hello. Okay. Any doubts, guys? I am not getting any comments, so I feel that there are no doubts. All fine, no problem. Okay. So now, as I said, now we will be going to one more concept. And before that, let me just tell you one thing, guys. We have discussed around 2-3 questions on binary search. Now, I will give you certain questions on binary search that will help you to identify important questions regarding binary search, and I'm sure and 100% sure that if you follow those questions, you can easily master binary search for placement jobs. Okay, so make sure you do it. I'll just write down the questions. Very important. First one, as I said, we have already discussed square root of a number. Second one, we discussed first, last, total occurrences. Third one that we discussed was missing element. Okay, and there is one more question that might be asked to you. It is called peak in a mountain array. Question: peak in a mountain array. 1, 2, 3, 4, 2, 1, 0. For example, see, 1, 2, 3, 4 increases till 4 it is increasing, again 210 decreasing. This is the peak. So you have to find the index 0, 1, 2, 3, third index. For example, this can also be solved using binary search. Okay. Other questions, very famous questions, important questions. 1, 2, 3, 4. Let's write 5 here. 5. Search in a 2D matrix. Normally we apply binary search on a 1D array. Now in case of 2D array, let me show you the question as well. Very important. I just joined. Bobby, sir, can you explain once more to find missing element in an array? Okay, Bobby says this. I'll do that. Let me give you the questions, Bobby. You do one thing. Just note down all these questions and I'll give you this thing also. Don't worry, I'll tell you. Okay. Let me just go to Google and show you something here. Search in a 2D matrix. It is a lead code question. This question, very important question. You can see the difficulty level also, guys. Please remember that the difficulty level of this question is medium, and it's a very famous question. Please go through this. If you want me to explain all these things live in front of you, let me know. I'll do that definitely. Okay, so I need motivation, guys. I need motivation from you people. Much love from you people. You guys have already supported me. I need more support so that we can make this live sessions more productive, more informative for you guys. Okay, for that we need nothing. We need more viewers who are watching and asking questions. Okay, for Bobby, definitely I'll explain that once again. Don't worry about it. Okay, so this is a question, as I told, the difficulty level is medium, so obviously this has been asking lots of companies. Okay, I am giving you other questions also, as I said. Let me just go back here. Applying binary search in a 2D matrix. And how do I say binary search? Let me just show you this. O of log m into n. Because it is a 2D matrix and it is not equal, you can see it is 1, 2, 3, 4. 3 cross 4 matrix, right? This is not a square matrix. So it is log of m. M is the number of rows and n is the number of columns. This kind of questions. Okay. Fine. Next one. Number 6. What other questions on binary search? I'll say aggressive cows. Very famous question, very important question, binary search. Okay, number 7. Painter's partition problem. Number 8. Book allocation problem. These are very commonly asked placement drive questions in big companies also. You can talk about Google, Microsoft and all. Okay. See, the concept is something like this. Whenever the package is high, the time given will be a little bit less and the complexity of the question will be a little bit high. So if you study these questions in binary search, I bet on you, you can crack at least around 80 to 85% of the placement drives. These are very important questions. Okay. So if you really want me to explain them in the sessions, I need some motivation. That is what I need, guys. I need you people to make me believe that yeah, whatever I'm doing is worth it and you really like it. Then definitely I'll be covering these questions. Okay, so Bobby says, I think you solved this search in 2D matrix when you came to our college. Yes, definitely I have done that in your college. Okay, so let's do this. Just for your request, Bobby, I will just cover that topic again for you. I have done it for you. So as I said, let's go through that question once again. Okay, we were trying to find the missing element, right? Because see, as a educator or a trainer or a teacher, it is really very helpful for us when someone says that, yes sir, please explain that again. Obviously, let's do it. So 1, 2, I have 3, I have say 5, I have 6, 7, 8, 9. So you can see this is 0, this is 1, this is 2, this is 3, 4, 5, 6, 7. And if you see the area, this is where it is. Okay, this is the missing area we have to target. So just remember one thing, as I said, index or element is equal to index plus 1. This is our formula. So if you see at 0th index, element is 1, 1 is equal to I is 0 plus 1, 1 is equal to 1. Makes sense? Similarly for index number 3, if you see 3 is equal to 2 plus 1. So that's why element is equal to index plus 1. Okay. So whenever this criteria is fulfilled, that means we are not having any missing element. The missing element will not fulfill this criteria. That is where we need to search. Okay. So let's do it. As I said, this is our start value. This is our end value. So mid is equal to start plus end divided by 2. So it will be 0 plus 7 divided by 2. This is 3. Okay. So let's see. At index number 3, what do you have? Index number 3, we have 5. So if our ARR of mid is this formula, same thing, not equal to, not is equal to mid plus 1. Mid is nothing but the index. Okay, if this is not satisfied, that means something is wrong. We are not at the correct place. Okay, we have to go to that side. Try to understand, okay, what I am saying. ARR of mid is what? 5. 5 is not is equal to mid plus 1. What was the mid? The mid is 3, right? 3. 3 plus 1. So 5 is actually not is equal to 4. This is true. So if this is not true, if this value is not giving us the answer, our missing element, obviously all the elements to this side will never give you the missing element because this is not following the property, this property. So where do you go? We go to that side. Make sense? So what do? You just say end equal to mid minus 1, because if 5 is not matching, if this value is not matching, the 5, obviously 6, 7, 8, they will also be not matching. This is mismatch this side. Let's go to that area. Okay. So if other case, if our ARR of mid is equal to mid plus 1, this satisfies, right? If suppose, let's see here, say 0 is the mid, 0 plus 1, satisfying 1, 1 plus 1, satisfying 2, all are satisfying. So that means if this is okay, I will never find the missing element this side also. So in this scenario also we will not find, in this scenario also we will not find. But this scenario we cannot go to this side, right? We have to go to start is equal to mid plus 1. Make sense? Go to this side. When this mismatch is happening, go to the right side, left side. When this mismatch is happening, that means when everything is satisfying the criteria. See, 1, 2, 3, 4, 5. No problem at all, right? No missing element. Similarly, 1, 2, 3. No missing element. So why do I bother about searching here? I have to move my start from here to here somewhere. Okay. But when we are going to the left hand side, we have to think about some conditions. Think like this. Okay. So let me just erase this part. When we are going to the left hand side, there can be two conditions to find the value. The first condition is if our mid is equal to 0, that means we have reached the extreme left. Array index 0 is the minimum index that we can have in the array. Or in this case, if we have reached here and we are not satisfying the equation, at 0th index we have the missing element. What will be the missing element at 0th index? Obviously index plus 1. What is that? 0 plus 1. We are returning mid plus 1. Mid is 0, mid plus 1 is what? 1. We can return mid plus 1. Correct? That is one condition. Otherwise, see, there is one scenario where ARR of mid minus 1 is equal to mid. This is also one scenario. Try to understand. Imagine ARR of, I have a mid 4. 4 minus 1, I am writing equal to what is the mid? 4. Okay. See, ARR of 4 minus 1 is 3 is equal to 4. Is it true? Try to understand. Is it true? What is ARR of 3? So, have I written anything wrong? No. In this case, I should not be taking this value. Let's take 3. Sorry, my bad. Let's take 3 here. And 3 minus 1, and let's take 3 here, so that I can relate it to this example. 3 and 3. What is 3 minus 1? 3 minus 1 is 2. ARR of 2 is 3. Is it true? Check and tell me. Is ARR of 2 equal to 3? Yes. So whenever you are having this, see, while going to the left, either you will find 0, where you find 0 you are returning plus 1, and one more condition where ARR of mid minus 1 is equal to the mid. That means ARR of 2 is equal to the mid value. That means you have found the loop. Return 2 plus 1. Okay. That is the missing element. 2 plus 1 means not 2 plus 1. What is the value that you have to return? 3 is not the missing element. The missing element is 4. Here is the missing element. So in this case, you are returning 4, or here you are returning 4. Did you understand how it is? So let me clean it and write it properly so that you can understand that. Otherwise it will be too much confusing. Let's write in one more time. Simply ARR of mid minus 1 is equal to mid. So what happens here? Say for example I am saying mid is equal to 3. You found something like this. So ARR of 3 minus 1 is equal to okay, what is the mid? Mid is 3 only. So in that case, ARR of 3 minus 1 is what? 2 is equal to 3. Is it true? What is ARR of 2? ARR of 2 is 3 only. Correct? This is the number that we are searching for. This is 3 only. 3, right? But is 3 the missing number? No. Then in that case, when you have come across this condition, what will you return? You will return mid plus 1, because that is the missing element. What is that? 3 plus 1 is equal to 4. This condition you have to remember. Then you are getting the answer. One more scenario where you will return mid plus 1 when your index is 0. When your index is 0 while going to the left, then also you return 0 plus 1, that is 1. Because if 0th index is the missing index, the missing element will be 1. These two cases. Make sense? I hope now you have understood this. Let me know if you have understood. And here is the code. Not this one, the other one. Yep. See guys, as I told, if it is normal, as I said, if everything is going normal, then we shift to the right hand side, because we need to find the mismatch area. When we have found the mismatch area, when our area of mid is not equal to mid plus 1, this is the mismatch area, then we go to the left. So while going to the left, we see if the mid is 0, then return mid plus 1, or else as I found that criteria, this criteria that I am talking. If our mid minus 1, ARR of mid minus 1, that is 3 minus 1, index number 2 is equal to mid, the formula, then also will return mid plus 1, that is 4. That is actually the missing element here. Okay, this is how it works. Okay, even understood the logic, sir, but it's only useful when we want to find a single missing value. But if there are multiple missing values, then we have to run same logic in a loop, or I am wrong. See, there will be only one missing element. In that case only it will work, okay? And obviously, as I said, in Prisa says she has understood. Fine, no problem. So, yes, absolutely, you have understood it fine. The point is there will be only one single missing element, then only we will be using this. Okay? What you were saying is absolutely correct. In that case, you will be doing this. Make sense? So, otherwise this quotient will not exist. The point is, once there is one single missing element, not this one guys, sorry, this one. See, 1, 2, 3, 5, 6, 7, 8. In this case, you can figure out that 4 is the missing element. That's why this quotient exists. Otherwise, there is one more point when 1, 2, 3, 4, 5, 6, 7, 8. Here nothing is missing, right? In that scenario, as I told you, what will you return? You will return 1, 2, 3, 4, 5. Nothing is missing, right? You will return ARR dot length plus 1. The length is 1, 2, 3, 4, 5, 5 plus 1. Obviously, the next element will be the missing element. The quotient has been figured like this. The quotient is like that. Okay, now I hope you have understood this. And okay, fine. So, all of you, please remember this quotient, very important, as I told you. Let's get back here and show you here. Please, 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 if you want to take a screenshot of this, you can take that. These are very important questions on binary search that are frequently asked in the placement drives. Square root of a number and first class total occurrences, missing element, peak in a mountain array. I have given you the example. Say, let's write down, say 1, 5, 9, 12 and then say 6, 5, 2. See, this is the peak of that array. You have to give the index 1, 0, 1, 2. Third index is the peak value, the highest value. Again, it decreases. This is looking like a mountain. That's why it's called like this. Then we have this search in a 2D matrix, and then you have aggressive cows, painter's partition problem, and book allocation problem. Guys, these three are very, very important questions. Okay, so make sure you take a screenshot of this and try to practice them. Okay. Source, as I told you already, you'll get it in LeetCode, or there is one more platform where you can get these questions. It is Coding Ninjas. And guys, one more thing. Search in a 2D matrix, finding the missing number in an array, pick in a mountain. Yeah, he has written it down. Okay. Thank you for writing it down, Bobby. Okay. So one more thing, guys. Hope you have understood this now, and think about the question only. Okay. Based on the question only, you can solve it. And as I said, one more thing, very important. Yep. We will talk about some other concepts also at the end of our DSA journey. DSA can never end, guys. There will be lots of questions coming up in our minds. So it's a very important concept called bit manipulation. This will be discussing later. Okay. So agenda. Let me discuss the agenda with you. Okay. A little bit. We have covered searching and sorting. We have done that. After that, what we will do is we will cover our linear data structures, say stacks, queues, linked list. We will not be focusing more on implementation. Okay, we will do the implementation, but we will be solving some questions also. Okay, and guys, this playlist will be from scratch. So we will be learning stacks, implementation, queues, and linked list. We will do that, and I will create a dedicated live session only for questions. If you need that, if you really need that, we'll do that. Okay, because if we just keep on going to questions, there are hundreds of questions that we can discuss. So what we'll do, we'll cover the implementation and we'll solve around 1-2 questions in every video, so that we can understand that okay, we have learned the concept properly. That is how you should do it. Learn stacks, questions, learn cues, questions, learn linked list, questions. And then we'll go to non-linear, that is trees, we'll go to BST, and then we have what? We have heap, very important. Heap is also called complete binary tree, CV tree. And then guys, very important, most of the colleges, I don't know why they don't teach this topic, trie data structure. We'll learn about tries also, okay, we'll solve questions also, and then we'll go to graphs. Fine, all the concepts. Then obviously we have algos. In algos we'll go to what? Greedy. Then we'll go to bit manipulation, as I said, bit masking. Also we have backtracking, very important. Okay, this we'll discuss, and then we have DP also, dynamic programming also. These are the things that we discuss. Okay, and as I have written one thing, I hope most of you will know that, but many people don't know this. I have mentioned it in the thumbnail, Cadan algo. This is a very important topic. So this also we'll discuss. Stay tuned with me. We'll discuss a lot of things. And the only thing that I need, it will be helpful if you can share most as interviews topic wise in a PDF or something. Okay, yes, Prisha, definitely I will do that. I am creating a comprehensive PDF with most of the questions that are asked frequently in interviews. I will definitely do that, and at the same time, in the meantime, you guys can do one thing. All of you, just go to this website, 450 DSA. This website, 450 DSA Cracker. Please visit this website. It is a very good selection of topic-wise questions. Go there and try to understand the topics. Click on array. I have been searching for shoes, so that's why it's showing me shoes. Okay, suggestions. Okay, so yep, you can go to this. See, there are 36 questions on arrays. You can see 0 out of 36. So once you have done this, just click on this checkbox. It will say 1 out of 36 done. And click on this checkbox. Now you don't have to go to Coding Ninjas or LeetCode to search that. You can directly go to this link, click on this, automatically it will open GFG or this Coding Ninjas. Start writing the code. Okay, that's the best part of this website, 450 DSA Cracker. Just go there and you can easily solve the questions. Okay, if you finish this, I bet on this, you can cover up any placement drive. Doesn't matter. You can easily crack all the interviews from this, because the best part is topic wise everything is given. See, arrays, matrix, binary trees, tries, as I told you here, trie data structure, very important data structure. Okay, so make sure DP, bit manipulation, everything is there. Even greedy you will be having somewhere. Yes, you have that here. Lots of questions, guys. I don't even need anything else. You can start from here, you can finish off this. No need to finish 450 also. Finish around 10 from every topic, you will be good to go. Try that. Okay. Definitely, Bobby, you will be doing the implementation of all the data structures. Be with me on the channel, be with me in the live sessions. Guys, I'll try to come Monday to Friday, everyday live, but if sometimes because of some reasons, maybe I'm late from college, maybe I have some in-house classes also, then bear with me and wait for it, and at least 3 days in a week, definitely I will try to come live. Okay, so thank you for all your patience. It's really been a good support from you guys, and yes, I hope to get more support from you guys in future, and tell your friends also that we are learning DSA together, and any doubts, anything, please comment that in the comment section. And yes, please subscribe to the channel and hit the bell icon for more content like this. And in today's concepts, we did not cover this. It will take a bit of time, so what we will do, we'll do this in the next video session, maybe tomorrow or day after. Okay, stay tuned, and I'll try to come at around 6 only, so that it is convenient for you people also. I think 6 to 7 is the better time for you guys, so I'll try to come at that time only. Okay, so thank you for watching again. Till the next time, this is Saurabh signing off. Bye bye and happy learning. Bye guys.